Alrighty, so picking up right where we left off in the last video, we saw how to do minting NFTs with Rust using just Solana's crates. But we haven't touched metadata yet. And that's because creating metadata is a little bit trivial. You can create additional accounts, do it all manually the way we did in the last video. But I'm going to show you guys how to use Anchor and Metaplex to actually make this process a lot more seamless. So Metaplex is really just designed to create structured accounts that represent metadata for NFTs. It's kind of like a metadata standard that they're trying to push on Solana. So far, pretty successfully. So they make that pretty easy. And then Anchor is an entire framework for Solana. So there's, TypeScript SDKs, there's crates for cargo. So you basically get SDKs in both your TypeScript code and your Rust code that helps you work with Solana a little bit easier. And one of the big things is helping you create transactions easier. So with Anchor, we're going to replicate what we did in the last video, but using Anchor's methods. And we're going to see what that looks like. And then in future videos, we'll kind of build on that. So if you made it this far, that means you've got at least Node.js and Rust installed in Solana. So you're going to want to just get the Project Serum Anchor CLI. So I'm going to do that right now. And I've already got it installed, so that'll be pretty quick. And now, once you've got that set up, you want to do Anchor init, and we're going to call it Mint NFT. And this is going to create a whole new repository for you. And it'll even do like your .git folder and everything. It tries to basically give you everything that you could think of that you're going to need. So let's open this up and see what it gives us. So this is everything that Anchor init will give you. It sets up Yarn for you. It gives you a tsconfig, your package JSON. It even sets you up with some dependencies right out of the gate, including Anchor, right? And then when you're used to writing scripts here in your package JSON for NPM, you instead can write them here in Anchor TOML. And we'll come back to this in 1 second. I just want to mention this is your cargo workspace, so you'll be able to write more programs in here, and this will pick it up. So some pretty neat stuff. They're also working on like modifying your deployment. Like you could have a deploy script here. But this is going to be the one that drives the whole thing. This is the baby here. So this is where your configs come from for your local setup. The first thing I want to do is change localnet to devnet, since we're going to be working with devnet. And this is going to be the key pair that we're going to use. That's fine. That's my default one. It's a devnet key pair, but just for future reference, if you want to change it right here. And as you can see, we've already got a test script set up, which is just going to run our test right here. So we'll come back to this. We've got this laid out as a nice little test. So to start, let's slide over to our program here. And as you can see, there's some boilerplate there for us already. So Anchor uses this declare ID, and that's to tell the rest of your program what itself's address is, like what its own program ID is. And that's for different kind of checks and stuff that we're going to maybe see. So we're going to toss in the use statements, and with them are going to come our cargo TOML configs. So we'll overwrite this here. So we're going to use a little bit from Anchor Lang, a little bit from SPL, and a little bit from spl-token metadata. And like in the last video, SPL is going to have both token and associated token. And here's system program. So you guys can kind of see the similarities already. So quick flop over to cargo TOML. We've already got Anchor Lang, but we're going to go ahead and add Anchor SPL. And we're going to go ahead and add the MPL token metadata dependencies. All right, so that sets us up there. All right, so back in our librs file, you can see here that this is actually all we need to create a program. So we don't need any more of that entry point. We don't need to set up that, like function header and stuff. You just have this pub mod, and this inherits everything you need to set up a program. And you can actually define more than one function in here. But we're going to just start with mint for now. So we're going to have our public function mint. And that is going to be basically everything that we included last time. So the way Anchor wants you to do this is they want you to pass in what's called a context. And that's going to be this struct here right now, but we're going to change it. That's going to be a struct of accounts. So in the last video, when you saw something like this, we were iteratively going through all of these, right? Like we passed a whole list of these and then we iteratively pulled them back out. With Anchor, you use a struct. So we're going to actually create a struct that looks just like this. So we'll start by changing this to mint NFT. And so we'll change that also up here. And we want to actually add this lifetime specifier here. Anchor uses info. And so the first thing we're going to do, the first account we'll add is going to be what's called the metadata account, which we've heard so much about so far. And this is going to be what's called an unchecked account. And that means we don't have to try to define and tell Anchor what type of account it is, because we're actually going to be creating it in our function. So we don't want Anchor to go and try to like validate that this thing exists. Now, whenever you pass in an unchecked account, you have to actually add this comment here, this check comment, and write a little message. And Anchor will actually stop you from deploying about that. So anytime you use unchecked account, add this. So we're creating this with Metaplex. And we're also going to be creating what's called a master edition metadata account. And these are just two different types of metadata. This is your basic metadata, and then this is the master edition metadata, and we'll see what that really means at the end. It's just another type of metadata that, like I said, Metaplex is kind of using a standard for. And you'll see Solana Explorer actually has support for this as well. So that our next account is going to be the mint. And notice we're borrowing all of these as mutable, right? So they're going to be able to be changed. The mint is the signer again, like we saw in the last video. And now we're going to add the token account. And again, this is one we're going to be creating in this program here. So we want to add that check. And this time I'm going to say, like, we're going to create this with Anchor, right? So these two are going to be created with Metaplex. This will be created with Anchor. And then we want to add, finally, our mint authority, which is going to be the wallet. That's, again, going to be a signer as well. And now the rest of these we saw in the last video, these are going to be the different programs, the system or token programs that are involved. Same ones as last time. And now lastly, Metaplex is going to check this last one. And it's going to be the token metadata program. That's Metaplex's program. It's on chain, and we're going to use it with a CPI, cross-programmification, and we're going to hit it to create some metadata. So anyway, I'm going to add some output like we did last time to mark our steps. So I'll go ahead and do that now. All right, so as you can see, same exact steps that we've been working with. Same exact steps as the CLI, same exact steps as the just Solana Create 1 video from the last time. Create the mint account, initialize it as a mint, create the token account, and mint to it. Those are the same steps we've seen time again. And this time we're adding 2 additional transactions to create associated metadata accounts. Like we talked about kind of iteratively, we've kind of like hinted to what these things are. We're going to actually create those in here. And you're going to see that that will allow stuff like the Solana Explorer and wallets to link those together and pull together all the metadata for your NFT. All right, so starting with the first one, we're going to mint NFT using Anchor syntax here. So we're going to use system program, create account. And that's, of course, coming from Anchor Lang, system program. And we actually get these outputs here like we've seen before with Rust. So we're going to replace these. The context, this is where Anchor kind of takes over here. Is you want to see how this is set up with context, just like our program is set up with context. So this is how you have to set up your CPIs as well. So Anchor comes prepared with CPI contexts that you can create and use, and they help you kind of like build your transaction. So we're going to create a new CPI context, and every CPI context takes a program ID and an instruction. So it knows what program to hit and what instructions to bring to it. So in this case, we're going to reference the context that came into our program. We passed the token program in, so we're going to use that. And we're going to do this to account info. Everything's account info in these CPI contexts. And so we're going to use system program again. And we're going to use the create account instruction. And that takes two fields from, and this is a long thing to type out every time. This is going to be from the mint authority, our wallet, and it's going to be to the mint. Straightforward, right? Our wallet's paying for it. We're going to create the mint. Land ports, again, I'm just going to do one sol, or whatever this is. I think that's one sol. Again, the 82 for size. And now the owner is actually going to be the token program. Like we've been saying, the token program owns this account, so it can write to it. All right, so that's mint. Now I'm going to go ahead with the same structure. You know, like we saw in the last video, we switched from system program to token program to associated token program. We're going to do the same thing here. But all of these Anchor CPI transactions are going to look like this. They're going to create a new CPI context, program, instruction, any other additional parameters. And that's how they're all going to be set up. So I'm going to blow through these now. Initialize mint. Alright, so there's initialize mint. And notice sometimes you do actually have to flop around between key and account info. That's usually in just the params. So when you're ever in your params, it's usually going to be a public key that they're looking for. But when you're doing the CPI context, that's all account infos. So just be mindful of that. So here we got 0 decimals for the mint. And we're going to be setting the authority here as the mint authority. We also set the same person as the freeze authority. It's optional, but we're going to have it set to the same person. All right, so now create the token account. All right, so that's to create a token account. Notice that the program ID is the associated program ID, but we're still passing in the token program down here. So just something to note, this is where we're going to use that associated token program here. And if you saw the last video, that's exactly the program that does this operation. All right, so now we get a mint 2. And of course, we're just minting 1, right? So there's mint 2. And now we're going to set up these metadata accounts. But before we go any further, just keep in mind that this is exactly the same as what we saw in the last video, right? This is exactly the same as the raw NFT mint using just Solana crates. And that looks like this, right? So it looks exactly the same. This is now represented in a struct down here. And then here's each of our transactions. You can tell that they look pretty similar. See? So you get it. Now let's do these 2 additional new guys. And these are actually functions that come from Metaplex themselves. All right, so that's how we do create the metadata account. You can see we've got this function here that'll give us the instruction we need. And we go ahead and invoke with the CPI. And this is going to be the token metadata program that we're invoking. So a lot of these fields are really just different metadata configs. So there's things like royalties and stuff like that you can set up. I'm not going to get into all that right now, but if you want to take a look at some of the docs for this, you can see what the capabilities are with this metadata. So notice these 3 variables that we added here. I'm actually going to add these as parameters, instructions to our program. So I'm going to show you how Anchor kind of does instructions for you. So you don't have to create a struct or an enum or do all kinds of like Borscht serialization when you want to pass in things like strings or numbers. Anchor lets you just define them as function parameters, and it will take care of all of that. So if we go back up to the top, we just have context in here, if we want to add instructions, all we have to do is just a plain old Rust parameter type. So pretty simple, right? Like pretty easy. It's a lot easier than trying to do some of the painstaking work you've seen me do in the last few videos. Anyway, now that those are set up as parameters, they'll be recognized down here. We're going to use them as what they sort of represent: title, symbol, URI. URI being the metadata itself. And so this account technically stores a lot of this on chain, but ultimately what this URI points to is off chain, at least in our example. So keep that in mind. Anyway, the last one is going to be the master edition address. And this is where you can get into some of the more details about royalties and like limited editions and all this cool stuff you can do with NFTs. This is what MPL token is really designed to do. So again, we're going to invoke. All right. And that right there is how you create the master edition metadata. So again, take a look at this function, take a look at all the different options that Metaplex gives you for that. But either way, let's go ahead and press onward. So we got our struct set up, all of our instructions, or all of our accounts are set up in this struct, and then our instructions, we said Anchor is going to easily allow us to do this. So let's make sure that this thing builds okay. And let's go ahead and do Anchor build. All right, so I spelled initialize wrong and I left a reference in. So let's quickly fix those. All right, so we're good. I just had to remove a few references. Whenever you're using account info, you shouldn't be using a reference. Only when you're referencing public keys. Anyway, so that this is all done, we're going to use Anchor deploy. And that's going to do what it kind of sounds like. It's going to go deploy your Solana program. But one thing to keep in mind is when you first start with an Anchor project, you actually get this default ID right here. And so you'll have to deploy your program, get your new program ID and swap it, and then redeploy the program. It's kind of annoying, but it's a nice little feature once it's done, because then it'll automatically replace itself. You don't have to go take any programs down or anything. So when this finishes, we'll go do that. All right, so as you can see, we've got our new program ID here. Gonna go toss it in. And don't forget to also add it to your Anchor TOML. Anywhere you see that FG guy there, FG6, whatever. And now that that's done, we're just gonna run Anchor build and Anchor deploy. And while that's deploying, let's go build out our TypeScript code. So you can see Anchor already sets you up with these tests. And right up here, this is an important piece. This is actually going to be pulling in a generated TypeScript file that Anchor is going to build for you based on the contents of your program. So you'll be able to use your program as a TypeScript object, like as its type. So we'll see what that looks like. First thing we're going to do is in this test, I'm going to get rid of some of this boilerplate here. We're going to describe our constants here. So we'll do test NFT title, and we'll set this equal to YouTube NFT. We're going to do the symbol, tube, why not? And then test NFT URI. Now this one, I'm going to get a little fancy here. What I'm going to do is I'm actually going to create a folder, not here, up here, called assets. And in that folder, I'm going to create this example.json. And this is just a metadata JSON example that we're going to be able to see. And that looks just like this. We're going to pop into the repository. This is the repository that's going to be linked in the video. This is the one we're working in right now. And we're going to find it right here. So what you want to do is click raw. And we're going to use this URL as our metadata here. Paste that in there. That'll be on the GitHub repo. And so now those are our test params there that we set up. So now let's go ahead and fill out the rest of this test. So right here, Anchor Set Provider, this is actually going to be setting up what they call a provider, which is going to be your local setup with its configs, your wallet, what have you. So I'm going to set this up just a little bit differently. I'm going to do this constant provider, set it equal to that we just pulled out. And so now we can do const wallet equals provider.wallet as anchor.wallet. And that'll just make life easier working with the wallet type from Anchor. And now we can just set the provider to provider. Nice. And now we also can get our program by just going through anchor.workspace. And here's where we're going to pull in that type. We're going to pull in mint NFT. Nice. And we'll set it as anchor.program mint NFT. Very nice, very nice. And that'll make things easier to work with, which you can see we already have down here, but whatever. Anyway, going onward, the last thing we want to do is add the token metadata program ID. And I couldn't find this in the SDK anywhere. Metaplex does have an SDK, but the docs aren't really available at the time of this recording, so I just went and got this on the web. That's going to be the token metadata program from Metaplex. So anyway, let's change this to mint for our test. And now the first thing we're going to do, let's get rid of all this junk, is we're going to derive the mint address and the associated token account address, just like we did in the last video. And we're actually going to do it in the same way as the last video's client side. So we're going to set up a new key pair. Now we're going to get the token address. And there's actually a function that you can use in Anchor utils called associated address. We pass it this struct with the mint key pair, the public key of that, and the wallet's public key. And that'll give us what the token address should be. And then we're just going to add a little bit of output. So we're going to say like new token right there is the mint. And now the next part is we want to derive the metadata and master edition addresses. And these are just going to be the addresses. So I'm actually going to paste these in one at a time. So here's the metadata address. We're just going to find this program address. And this is just going to look up a program address with seeds. You know, this is going to find a program address that can exist on Solana with these seeds. And we're going to use that to create the address that points to the mint. So here you can see metadata is the seed. We use the metadata program ID as another seed and the mint. And it's owned by the token metadata program ID. So the exact same thing is going to be for the master edition. There's just one additional seed that goes with it. All right, so there's those two metadata accounts. That's how we get the addresses of them. And lastly, our final step is going to be transact with the mint function in our on-chain program. And so we're going to do await program.methods.mint. And that's just it. You can use .methods.mint because we've got it as a type. And although it doesn't say it's resolved right now, it will be eventually. And this is going to be how we use the different functions that we defined in librs. So one thing to note is librs, our mint takes the context and then these three parameters. But you don't actually have to pass the context as a parameter. So I'm going to leave this alone for now to show you that what you do is hit .accounts. And that is where you put your accounts. You put your signers in here. And you do .rpc to finish this thing off. And that's it. So let's fill this thing out, right? So obviously we know that we're going to do our title, our symbol, and our URI in that order. And so that's good for parameters. Now for accounts, In the last video, you saw we had to make this huge list with everybody had to be designated as a signer or not a signer, or writable, not writable. That's already been declared in here. We've already done that in our struct. So Anchor is going to look for all of that information on the entry. So all we have to do is provide the public keys. So master edition address, metadata address, and I'm just going to blow through this. All right, and then finally our signer is just going to be the mint key pair. And this is actually going to be signed by our wallet as well. So that's it for using Anchor. That's how it's all set up. And just to take a quick look, notice we don't have all of the accounts in here that we specified in the struct. So we don't actually have to pass these guys because Anchor will resolve these themselves, including rent. All we have to do is pass these ones, which we've got, and then the token metadata program because it's unchecked. Cool. So let's go kick this thing off. All right, so there you can see we've got a successful test. And now, I'm not going to really pull up the logs because you know what it's going to say, but let's take a look at what our NFT was called, YouTube NFT. And we have from the output here, let's just go ahead and do Solana address. We'll grab this address and we'll go look it up on Explorer. So here's the wallet. Flip over to DevNet. And if we look at tokens, there's YouTube NFT. And there's the picture that we have in our metadata. It's a master edition, as you can see, because we created a master edition account for it. There's some metadata in here. We don't have any of this detailed, but this is how you can add different metadata. And yeah, as you can see, we got the picture. That's the most important thing. So this is pretty awesome. It belongs to our wallet. And one thing I want to show you guys about this thing is, remember how I said if I go to this GitHub repo, I said that this NFT's metadata is just chilling right here, right? So if I go ahead and actually edit this, and I want to just go like, let's just go get like a picture of SpongeBob or something. If I just take this URL and I put that right here, instead of that rust crab, and save it, let's see what happens. So you can see that raw data has been updated with the new URL. Sometimes this takes a minute with GitHub caching. It takes up to like 5 minutes to see this happen. But if we go back to the Explorer, look at that. Our picture changed. But this is an NFT. This is immutable, yada yada. You can see this, the exact same address. It's the same ownership. This is our same NFT. The picture changed because our metadata changed. So just something I wanted to show you guys at the end here. Thought it was kind of cool. Like if you go change this JSON, you can change that NFT's artwork. So be really, really careful when you're buying NFTs out there. You know, make sure that you know what they're doing with the metadata, how it's being stored. There are decentralized solutions. There are high security solutions to securing that metadata, that artwork that you're buying. So just something to take note of. But anyway, guys, appreciate you tagging along. This is what it takes to build with Anchor. As you can see, we did a little bit more here with the metadata stuff, but the code is still pretty simple on the client side. It almost looks the same. And then even our program looks almost the same. It's just if you want to do things this way with Anchor, where you can pass all of these in as a struct. One of the biggest reasons is obviously to avoid all of the serialization stuff. But, you know, there's other features to Anchor that make it useful as well, including everything we've done with the CLI. So going forward, we're going to continue to use Anchor, learn a little bit more about it, and we'll check out some more cool activities in the future videos. Thanks.